Finally, here is the summary. First, we need to consider why generative AI is necessary, especially in the manufacturing domain. The first reason is to gain inspiration through exploring a wide variety of designs, or when you want to optimize complex shapes that cannot be parameterized. Another case is when the goal is not generation but prediction, yet there is a lack of data to train a predictive AI model, so synthetic data needs to be generated, and generative AI technology is advancing at a tremendous pace. Now, many have moved from GANs to diffusion models. These days, it's becoming possible to control various aspects in new ways. So, we need to think about how to effectively apply this to engineering design. Also, since LLMs themselves are advancing so rapidly, we need to consider how to use them efficiently in engineering design as well. And whenever we use generative AI models, there are always trade-offs to consider between the quality of the generated output and the diversity of the generated results. There is a trade-off. So, you always have to decide whether you want to generate only a small amount with high quality, meaning diversity can be lower, but quality must be high. Or if it's a generation task where diversity is more important for inspiration, even if the quality drops a bit. The next thing to consider is, thank you, is whether to generate parametrically or non-parametrically. If you really need to consider strict manufacturability, then designing parametrically is the right approach. So, for detailed design, you need to design parametrically. On the other hand, generating non-parametrically is more suitable when you want to ensure a certain level of diversity, or when you are using highly flexible production methods like 3D printing. And unlike the service industry, manufacturing has less data, so you need to think more about methodologies that can learn from small datasets, no matter what. And we also need to keep thinking about evaluation methods for diversity, originality, quality, and so on, and how we can effectively teach manufacturability to AI. And post-processing techniques for creating drawings are also extremely important. Or, after generation, post-processing techniques are needed to improve quality. I mentioned this earlier along with drawings. Next, while existing methodologies generate single parts well, assemblies are more challenging, especially in engineering. Assemblies require extremely precise interfaces, so we need generation methods that take these factors into careful consideration. So if we look at the process of using generative AI, first, if you want to develop a generative model, you need to check whether you have design data or not, right? If you don't have it, you need to generate seed data first. Since you can't use AI to create seed data, you have to either use parametric design, perform topology optimization, or have someone create it manually, even if it's just a small amount. After creating the seed data, you then train the generative model. When training the generative model, it's not just about generating data, you also need to use predictive AI to provide feedback. You can filter out whether a design is good or bad by generating it and then providing feedback. Or you can incorporate the evaluation method from the beginning of the generation process so that only those designs that meet the criteria are generated.